Okay, Lianet. Okay, you send me by, I have opened the laptop, and the laptop I see the chat. You send me your name with the chat, I copy in the piece of paper, while checking in the piece of paper. Okay, guys, today I want to practice a little bit about the trigonometry identity. I don't know if you understand very well the idea for the, in general, in algebra, identity is equation que is equivalent each other. Lianet, okay, Lianet, okay, Lianet, I get your attendance. It's equation que have infinity solution, no? Because they are equivalent, exactly the same. Do you understand this idea, right? Yes or no?
Yes, Professor.
Yeah, but the problem is in trigonometric is we have a lot of combination. Entonces frequently que happen this situation gets identity. Therefore, let me tell you one story. For example, I am teaching years ago a differential equation. I explained one student doing one way, and entonces now in the differential equation in this moment involve trigonometric functions, and the student get one answer. Okay, the answer is correct. However, the teacher can explain this, and the tutor, and the teacher can explain this, say it's wrong. And the problem was okay, the answer and another answer, they are identity. But sometimes it's not easy to see that. Okay, of course, you don't be scared because identity I discussing with you is no big deal. It's super easy. And the identity we're discussing in the review packet is super easy. And the identity you can see, you cannot see the board. It's a Victor Villamizar que no can see the board. Everyone saw the whiteboard or no?
Yes, Professor.
Victor, you are in big trouble. Okay, Victor? Kevin, say, I see the board. So you need to go outside, reload, I don't know. It's your problem, not my problem. Okay, entonces now, don't be scared. Entonces the student, how the student get your good grade? Leave the class and come back. It's the solution. Well, the student go to the Symbol Lab or another software. There are another software que es fantastic, que es Wolfram Alpha. Pero ese software, you put the identity and the software say it's true or it's false. Si es true, it's because the identity, o sea, the expression que he obtained in your test is identical, is of the expression que the teacher wants. Entonces, of course, the student get 100 points. But this is complicated. Entonces, in algebra, it's easier to see that. However, in trigonometry, no. In trigonometry, there are several combinations. When I bring one example one, I want to, okay, I want to put it in the PDF, o sea, on the whiteboard. Here, the famous trigonometric pages. Okay, I suppose everyone have that. Okay, I put it here because I want to work in simultaneously with the problem and check it out the identity, right? Because nobody memorize this everything. No. Pero little by little. Okay, example one say, proof, establish this identity. 2 cosecant square theta, or whatever, x, is equal 1 over 1 minus cosine theta plus 1 over 1 plus cosine theta. Prove that. Okay, I am totally lost. I have no idea. I try to do my best. And remember, my recommendation is you take the right hand side because we have more degree of freedom to manipulate this. We have only one expression. Entonces, I take the right hand side because it's the most complicated expression. And maybe I have more degree of freedom to manipulate. Entonces, I propose you condensing this in only one fraction. And the least common denominator is both. Because they are similar, but it's different factor. One is negative, another is positive, no? Entonces now, when you divide the LCD by denominator 1, es obvio que stay alive, 1 plus cosine times 1 is 1 plus cosine. When you divide the LCD by the second denominator is plus 1 minus cosine theta. Do you follow me? Do you follow me the thing we are doing?
Yes, Professor.
Super. Now I see, wow, cosine positive and cosine negative is cancel. And 1 plus 1 is 2. At least in the top, we have 2. In the bottom, you FOIL. Oh, no necessary FOIL because the shortcut to do this is, you know, que A minus B times A plus B is equal to the famous A squared minus B squared. Do you remember that, right? A is 1,
Yes.
A is 1, and B is cosine. So if you FOIL, you get the same answer, no? You want, I do. But I know my memory to make fast, que es 1 minus cosine squared theta. Do you follow me?
Yes,
Do you follow?
Professor.
Sure? Do you want I FOIL this or no? No?
It's not necessary.
No necessary. Okay, okay. Okay, entonces I take advantage this trigonometric Pythagorean identity. Que this trigonometric Pythagorean identity say que sine square theta plus cosine square theta equal 1. Therefore, sine square theta is equal 1 minus cosine square theta. So I solve for sine because this look like similar to this, right? Similar, no, identical. This is the idea. Identity, identical. Now I replace 2 over sine square theta. But I know very, very well que the reciprocal of sine is the cosecant. Looking in this trigonometry identity, look. Okay, entonces you replace. No sine square reciprocal anymore. This is 2 cosecant square theta, que es the reciprocal sine, because I know que cosecant theta is equal reciprocal sine. Of course, if both are square, it's because it's a square, and you get, wow, this guy is exactly the same as this guy, and you finish. Got it? Got it?
Professor, I have a question.
Mm-hmm.
So, Professor, we need to prove that the left side is equal to the right side, right, Professor?
Yeah, and the procedure is always, well, they are super complicated in which you need to manipulate both sides in order to get identical. And the more elegant way is you don't touch one side, in this case was the left hand side, never touch. I manipulate the right hand side until you get it's exactly the same. Identity. Got it?
I got it. Thank you, Professor.
Mm-hmm. Well, let me know when you finish the copy. Finish the copy?
Yes, Professor, I took a picture.
Okay, so I try to see. I put the meeting in my phone because Villamizar, you are all students. You know my way. Villamizar, are you sure? Can you click in the link I sent today? Remember, I sent different link. every day. Okay. Okay. Of course, I want to erase this because I'm using another identity, no? Okay, the example 2 is now. Example 2. Another identity is paréntesis cotangent square theta plus 1. Okay. Sine square theta minus 1 is equal minus cotangent square theta. Prove that. Well, I suppose in this example, we have to manipulate the left-hand side because we have more degree of freedom. I want to manipulate this in order to little by little put equal to this, and that's it. I prove case identity. Well, the first thing I see is this identity. Look, 1 plus cotangent is cosecant. So you replace. This guy is cosecant square. Cosecant square theta, paréntesis, sine square theta minus 1. Equal the same thing. Okay. Now, one more time, I'm using this famous identity. Let me manipulate, but not here in one corner of the piece of paper. Sine square theta plus cosine square theta equal 1. Therefore, look, sine square theta minus 1, I move the 1 to the other side, is equal minus cosine square theta. So you replace this by minus cosine square theta. Okay, by the way, there are no reason to have the minus here in the parentheses. I put outside like that, minus cosecant square theta times cosine square theta. Okay, cosecant I know que es recíproca of sine, es sine square theta. And cosine, okay, one good idea always is, you know, replace cosecant, secant, and cotangent by sine and cosine. Even the tangent using sine and cosine. And now I have minus cosine square on the top divided by sine square on the bottom, no? So you put a negative outside and you put the parenthesis and you put here cosine theta divided by sine theta and everything is square. You're using this identity is look. Cotangent theta is equal cosine over sine. Wow. Entonces this is negative cotangent square theta. It's exactly the same of the right hand side and you prove the identity. Super good or super bad? Any question? Guy, don't frustrate with this. I promise in the test I put easy example. Or not exactly easy, you know, example we are doing before in the review and the lecture. No, because they are sophisticated identity. Okay, I cannot solve it. I have experience, I cannot. I never get the answer because it's too complicated. In the real life, I explained that we have software. You put both sides, you press one button, it say true. Si it's true, it's identity, if false, it's no identity. Any questions so far in the example 2? Do you understand or no?
Yes, Professor.
Not necessary. They are different weight. Not necessary to do in the way I am doing. Some students doing a little bit different, but you get the same answer, no problem, I understand. But don't frustrate for this. Because it's really complicated. And you know, the graphic calculator when we are working in calculus with the trigonometric function, the final answer is expressed like a sine and cosine only. No cosecant, no cotangent, no using. That is the reason there are many combinations. And this is the thing. Try to prove identity using combinations. Number 3 example. Number 3 example, I don't want to copy directly the example. It's cosecant theta plus cotangent theta is equal sine theta over 1 minus cosine theta. Well, in this case, I don't know exactly what term I get the left-hand side or right-hand side. I want to explain one technique that's frequently using in this problem. Okay, is rationalize. Rationalize not necessarily is when there's radical. So you multiply by conjugate like that. Look. If you take right-hand side. Okay, I want to copy separately. Sine theta divided by 1 minus cosine theta. And you multiply by conjugate. Conjugate is 1 plus cosine theta. 1 plus cosine theta. This working like a smart one can help me to simplification the original problem. Get this. How? This is traditional, classical example. When you multiply, we have sine theta, parenthesis, 1 plus cosine theta. When you multiply here, I did before, it's 1 minus cosine square. Do you remember that? Do you remember?
Okay. Yes, it's the formula, right?
Yeah. It's the shortcut of the multiplication. When you multiply, this is the reason I select the conjugate, because any factor time is conjugate is a squared minus b squared. This is a special problem. Suppose I don't remember. You FOIL a squared minus ab plus ab in alphabetic order minus b squared. And all will happen is this cancel. I stay alive a squared minus b squared. Exactly the same we are doing here. Okay. Okay, so again, I'm using this identity. Look, yeah, I know this guy is sine square, correct?
Yes.
Es sine square. Okay, entonces I copy, recopy, and why no? Why no? You have, for example, sine theta 1 plus cosine theta divided by sine square, ¿no? Es obvio que at least one sine is canceling. One cancel and this cancel. And so far we have 1 plus cosine theta divided by sine. Only one sine. Let me say something important. In the trigonometric function, I don't know why. For example, when you talk about sine square, right, in this style, in this way. Okay, by the way, is equivalent to this. Parenthesis, sine theta square. Okay, this square actually is not applied in the argument. So this is completely different to sine theta square. No, completely different. This power is applied of the entire trigonometric function. But I don't know why. I suppose it's a shortcut. Okay, the exponent you put near to the trigonometric function, but it's equivalent to this. Okay. Do you understand the idea of this? Well, we almost finished. We almost finished because I split this fraction into fraction. The first one is 1 over sine theta plus cosine theta divided by sine theta, no? Wow, reciprocal sine is cosecant. Look at that in this identity. Cosecant. So this guy is cosecant. And cosine divided by sine is cotangent. Look at that in this identity. Yeah, I finish because this expression is equivalent to this. It's exactly the same. Twin brother. Any question? I understand your concern. Okay, I don't know how to start. When you start, maybe you are doing not too fast like me. You apply several steps, but you start, and we're using the identity that we have in the cheat sheet. Any question? Any question? Any question? Any question?
Oh, Professor, I have a question. So
Uh-huh.
we start like with the left side this time, right, Professor? Or
No,
we do...
in the right. I manipulate the right hand side. I never touch the left hand side.
Okay.
Boy, there are possibility to do it the other way, maybe. But in my paper, I do that. Okay? But maybe another student select this and manipulate backward in that direction, from this direction, and get the same answer. Okay?
Okay, I got it. Thank you, Professor.
There are no unique way to do this. Using your imagination and common sense and the cheat sheet, no? It's important. The cheat sheet is extremely important. Another example. 1 plus cosine theta divided by sine theta plus sine theta divided by 1 plus cosine theta, wow, is equal to 2 times cosecant. Cosecant theta. Another consideration que I explained before, but I want to emphasize. Normally, when you have sine, you put parentheses theta, no? This is the correct way because it's a function notation, you know? However, and you know, to do fast in the colloquial language of the trigonometry, you omit the parentheses, and this is okay. But you need to understand that this is the argument of the one special function that is trigonometric function, correct? So two important things. One trigonometric function, formally you put a parenthesis, and the square here is, or the cubic power, any power, cubic, suppose cubic, is sine of x raised to the cubic power. Okay? Well, in this case, it's obvious that we take the left-hand side. Why? Because you have more degree of freedom to manipulation, no? We have more possibility to manipulation. Entonces, es clásica la idea. When you have two fractions separately, you condense in only one common denominator. LCD is the combination sine multiplication 1 cosine. You take both factors separately, put together, and you form the least common denominator. And you divide, remember the formula, guys, LCD divided by denominator 1, multiplication by numerator 1. Again, LCD divided by denominator 2, multiplied by corresponding numerator 2. Who is denominator 1? This guy is denominator 1. Who is numerator 1? This is numerator 1. This is denominator 2, and this is numerator 2. Are you familiar with this idea or no?
Yes, Professor.
Okay, okay. The student can take with me intermediate algebra, remember, right? Okay. But either way, some people explain different way. But it's okay. You divide this divided by denominator 1. It's obvious que the sign is cancelled. The sign is cancelled. When you divide, the sign is cancelled. This is cancelled. And stay only 1 plus cosine theta multiplied by itself is 1 plus cosine theta square, no? Or again, repetition, 1 plus cosine theta, either way. Plus, this plus is this plus, and this divided by this stay sine, and sine is sine square. So far, everyone follow me or not?
Yes, we are following.
After that, you expand, but expand is different. Look, this expand is a special product also, que es a plus b squared. Es a squared plus twice ab plus b squared. Some students got lazy, don't memorize this formula, it's super easy. And apply foil. Let's do it quickly. Es a plus b times itself is a squared, ab again, and b squared. And this and this together is twice. Que es completely opposite to the conjugate. Conjugate is a special product. We have two special. Only two, no three, no four. It's easy to remember. A plus b times a minus b is similar situation, but this is cancelled out because it's opposite sign. The reason is a squared minus b squared. See, you memorize this, is super useful in algebra. This is special product. This is sometimes some book called quick foil, but it's okay. Okay, so how you expand this guy? Well, square it first. Okay, 1. And 1 squared is 1. Plus 2 times cosine theta plus cosine theta squared. Do you want I do for you using foil or no?
We can use the formula, Professor. It's better.
So, in my opinion, yes. Okay, super. Now I can see, wow, look at that. This guy is this guy. Let me make it zoom. The famous trigonometry function, trigonometry identity you're using every day. Look. So this is 1. So you replace 1 plus 2 cosine theta plus 1. You see that or no?
Yes.
Okay, and 1 plus 1 is 2, no? Okay, now factorization 2 is a common factor. Why not? 2 out. We have 1 plus cosine divided by sine, and we have 1 plus cosine. Wow, I like that. 1 plus cosine is the same factor, you cancel out, and it stays only 2 over sine. Okay, and who is that? Well, this is, I know this trigonometry identity. Look, reciprocal sine, cosecant, no? Look at that, this identity. Okay, therefore, you replace this for this, 2 cosecant theta. It's exactly the same, the expression that we have in the right hand side, and you prove the identity. Super good or no?
Super, Professor, can you zoom it, please, so I can
Yes.
screenshot? Thank you, Professor.
Okay, no problem. So can you erase?
Yes, Professor, you can.
Okay. Okay, let's come back to the next one. The next one say, this is a little bit complicated. Not complicated, it's a little bit weird. This is cotangent pi over 2 minus theta multiplication by cotangent theta equal 1. Okay. In this case, yes, you have cofunction formulas. Look, what is cofunction? Cofunction, this name, cofunctions. Cofunction, guys, so any trigonometric function have a cofunction. For example, what is the cofunction sine? Es cosine. You see it's cosines. This is the cofunction. What mean cofunction? Okay, for example, sine 30 degree is equal cosine 60 degree, que es de complementary angle. What is the complementary angle? Complementary 30 plus 60 is 90 degree. Complementary. Ajá. O sea, es pi over 2. 90, ajá, 90 minus 30. Exactly, es the fórmula. Entonces, en this scenario, we use the cofunction formulas that we have here. Look, specifically this one. Look. Y I know que de cotangent pi over 2, que pi over 2, you know, is exactly the same 90 degree, but in radian. What happened? What happened with that? What happened? What do you want? Do you want to get copy again the thing idea? Cofunctions? Okay, cofunction sine is cosine, cosecant is secant, tangent cotangent. Now the prefix co indicate cofunction. And what means cofunction? Que the angle is the same, pero complementary. So taking the cofunction formula, cotangent pi over 2 minus theta is tangent theta. So you immediately replace this expression for tangent. Tan cotangent equal 1. Okay. So I take this identity. Look at that. I know que cotangent is reciprocal of tangent. Entonces now, for example, tangent stays the same here. Y I copy reciprocal of tangent equal 1. And you see, wow, the tangents cancel out. And the answer is 1 equal 1. And you prove the identity. True. Suppose another student are doing different. Suppose another student, instead of replacing cotangent by tangent, using this another identity, look. So you have 1 over cotangent times cotangent. And you get the same answer because you cancel cotangent and cotangent, and the answer is 1 equal. Super good or no?
Okay, so we need to prove in this case that is equals 1, right, Professor?
Sí, you manipulate, o sea, you can, it's no illegal, it's no violation, manipulate both sides, pero it's independent. And you get exactly identity. But I see it. Okay. Oh, another way que es more elegant, you know, it's cosmetic. You don't touch one side and you manipulate left or right, depending the, and the selection is clear. The turkey you see more complicated, give me more possibility to manipulate Okay, entonces you take in this case, well, 1. Who is 1? I don't know. 1 is a number. Hello. So you take the other, right? Another example.
But Professor,
Go
we
ahead.
could do by 1 like sine plus cosine is equals 1. So we could do in that way that.
Okay. Maybe you're right.
Okay, thank you.
But you need to make a decision. You make a decision doing maybe you work perfectly. Yeah, respect. Suppose this minus sine negative theta divided by negative cosine negative theta is equal minus tangent theta. Well, in this example, I can see the property even odd. For example, using this sine negative theta and cosine negative theta. Even odd formulas. So I know that the sine function is odd function. However, the cosine is even. Entonces now, si es odd function, this negative go outside and meet another negative, and together is sine theta. The left side is tangent. Yeah, it's negative tangent. The right hand side is negative tangent. Entonces sine divided by, and cosine is even. Si es even, this sign is not important until you put negative cosine theta. Cosine theta. And this negative, if you want, you put in the front. And sine theta divided by cosine theta is, look at that, tangent theta. Yeah. Entonces es negative tangent, que es exactly the same of the expression that we have in the original right hand side. Easy. A ver, easy, nuela. Okay. Let me know when I can erase.
You can, Professor.
Okay. This look like horrible, but no. Look, it's cosecant 4 power theta, parenthesis, cosecant theta, multiplication cotangent theta, minus cosecant square theta, parenthesis, cosecant theta, cotangent theta, multiplication cotangent theta. Oh, is equal, let me move this. Is equal cosecant cubic theta times cotangent cubic theta. So prove this identity. Okay, let me try. I am completely lost. First of all, I have no recipe. So you apply identity, trigonometric, in the cheat sheet, or you apply first some algebra. I'm lost. However, I can see is your factorization. What is the greater common factor? In the expression of the left-hand side, you see that we have cosecant square theta because we have 4 and 2. The greater common factor is 2. And also I can see that this factor is common factor again, cosecant theta times cotangent theta. And stay in the next parenthesis, cosecant square theta minus what? Because I factor out, well, another way to see that. Cosecant to the 4th power is cosecant square theta times E cell. See, you factor out this and this, que is equivalent this and this. Inside the new parent, we have only this cosecant, okay, this cosecant is this cosecant. And in the second, we have nothing and nothing one. You follow me?
No.
No. What part is you don't understand the factorization?
Yes, Professor.
Look, I put in blue color, Nuela, the greater common factor. The greater common factor is cosecant square. Look, let me change the color. This guy is this guy, is also this guy. I factor out. And this guy and this guy is the same. I factor out again. Look, I factor out green and yellow outside. Who stay? Stay this cosecant, get this. And here nothing, and nothing is one. More clear now?
Yes, Professor, thank you.
Okay, now, what should I do when I am lost? When I come back to my famous Chichi and the Pythagoreans, I can see, look here, cosecant something, this one, look, this one. Let me recopy here. 1 plus cotangent square theta is equal to cosecant square theta. Cotangent square theta is equal cosecant square theta minus 1, no? So I move this one to the side. And this is exactly the same of this. Good. So in the next line, I copy cosecant square theta multiplication cosecant theta cotangent theta. You replace this by cotangent square theta. Okay, this is exactly the same of this. Make sense?
It does.
Okay, now multiplication. We have this and this together, cosecant cubic theta, and this and this together, times cotangent cubic theta. It's exactly like that. Boom. I got it. So in this example, we need to do some algebra first to accommodate a little bit the trigonometric expression to look like similar to the table, to the cheat sheet, no? Sometimes it's no straightforward, no? You need to manipulate. I am doing too fast now. But in real life, I need to think and try different way until I discover what the best way, no? Of course, I don't want to waste the time with you here. I go directly to the point. Because I did before, I have my piece of paper. And don't frustrate. I repeat again, because this is complicated. Suppose you need to apply this in your class of the calculus. Entonces now, sometimes it's almost impossible to prove that by hand. You using software, maybe Symbolab or Wolfram Alpha. Maybe in your moment I show you Wolfram Alpha. But I don't want to waste the time with this now. Okay, you copy that or no? You copy that or no?
Yes.
Okay. Okay, now, next one. Let me erase this. Okay, next one is parentheses 1 plus cosine 1 minus cosine negative theta is equal to sine squared. Prove that. Okay, wow, complicated. No, because immediately I saw negative theta, I apply the even odd formulas. This one. Look. So you replace is 1 plus cosine square theta and 1 minus cosine theta. Because I know que cosine is even function. It doesn't change independent que inside the argument you have positive or negative. Now, multiplication. A multiplication is the shortcut, the conjugate. It's 1 minus cosine squared. Everyone follow me?
Yes.
One more time. I'm using this trigonometry identity in which I know que sine square theta plus cosine square theta equal 1. Therefore, sine square theta, I isolate the sine, is 1 minus cosine. Now 1 minus cosine is identical sine squared. It's exactly the same we have at the beginning. Finish to prove.
This one is easy.
Well, no, sometimes yes, sometimes you see clear in 5 seconds, no? But sometimes no, sometimes it's very complicated. I promise it's very complicated. Some problem, I select a lot of, I have a bank of the exercise, and some exercise I cannot do that, because it's very complicated. But I don't frustrate for this, because I don't know, no, I know, but I don't see the way. Okay, because there are many possibilities. Okay, entonces this was easy. No es la sé que es easy, okay. I respect opinion. Some clue.
Sorry, this one, not all of them. This
Por ahí está. Okay. Move on to another. Suppose this guy is sine theta tangent theta divided by 1 minus cosine theta minus 1 equal secant theta. Wow. Horrible. Let me try to do my best. Es obvio que the best way is taking the left hand side because it's more complicated expression to manipulate. And one good idea, guys, is try to express everything using sine and cosine. No tangent, no secant, no cosecant, no. Entonces, one possibility is sine theta times, entonces, I know que tangent is sine over cosine. Using this trigonometry identity, tangent and cotangent identity, sine over cosine. Okay, this color is not good. Much better one yellow or blue. Okay. Entonces es divided by 1 minus cosine theta minus 1. This is theta. Entonces we have sine square theta divided by cosine theta divided by 1 minus cosine theta minus 1. So far, everyone follow me?
yes, Professor.
Because I propose you, there are no reason. This is stupid to have two fractions separate. No. It's a good idea condensing one fraction using the least common denominator, no? In this case, 1 minus cosine. Because 1 is just 1 over 1. What is the least common denominator between this expression and 1? This expression. So we have sine square theta over cosine minus this expression, que es 1 minus cosine. Okay. At least we condense it in only one. Now I remove the parentheses. Sine square theta divided by cosine theta plus minus 1 plus cosine theta divided by 1 minus cosine. So far, everyone follow me?
Yes, Professor. But this one is a little complicated.
No. This is your opinion. Okay, now why not again the same? You know, what is the strategy? The strategy condensing. Entonces, this is similar. We have fraction, and not fraction, but it's different denominator. Entonces, no, stupid. You find the LCD and the top part, que es cosine theta, and we have sine theta squared minus cosine theta plus cosine square theta. Make sense? Don't forget this part is the denominator, the original denominator, no? So the only thing I did was somehow condensing this part in only one common denominator, que es cosine. Make sense?
It does.
Now, wow, look at that. Immediately I see this idea. Sine square plus cosine square 1. One more time, we're using this famous identity. And you replace. Entonces, in the top, we have 1 minus cosine theta divided by cosine theta. And the bottom, we have 1 minus cosine theta. Do you see that? Okay, entonces now, you know que we can cancel out that part. Yes or no? So esto dice, no, professor, I don't see that. Okay, no problem, guys. You take the fraction and the denominator, that is 1 minus cosine theta divided by cosine theta. And you multiplication by reciprocal of this, que es 1 over 1 minus cosine theta. Now it's clear que this expression in the numerator and denominator cancel out. And stay only 1 over cosine. Y I know que reciprocal of cosine is secant. According to secant, look at that. Reciprocal of cosine is secant. According to this. Is secant. And secant theta equals secant theta, exactly the same in the right hand side. Do you see?
Yes, Professor, can you zoom it, please?
Sí.
Okay.
In my opinion, the most important idea in this part is that you are a little bit more familiar with the identity formula, the classical identity formula, que help us to establish or prove more complicated combination of this. Okay, so basically we're using always this page, and little by little you memorize somehow this identity to generate more complicated example. Entonces you need to be aware que in trigonometric we have no one unique expression. There are several combinations. This is too complicated. Too complicated. May I erase? Oh no, not yet.
Yes, you can, Professor.
Okay. Let's move on to the next identity, que is cosecant square. I need to prove que cosecant square theta minus tangent square pi over 2 minus theta is equal 1. Again, I see cofunctions. You see pi over 2 minus something. Another important thing, when I study the equation, we're using x, the independent variable, sine x equal 1/2. In identity, I use theta. There are no specific reason. You can have an identity using theta, using x, using u, using b, any independent variable. And here again, theta, whatever. There are no reason. There are no special reason. But it's a traditional way in the book. X and equation, but no, it doesn't matter. Okay, so now we're using again the cofunctions formulas. In this case, I'm using this function, look. Right? Tangent pi over 2 minus theta es cotangent, pero es square. Entonces es cosecant square theta minus cotangent square theta. And disappear pi over 2 minus tangent, I replace by the cofunction, equal 1. Okay, now this look like similar to this. Let me see. Using this identity is, I want to copy here to manipulate a little bit. 1 plus cotangent square theta is equal to cosecant square theta. So maybe you replace cosecant, this cosecant is 1 plus cotangent square theta minus cotangent square theta, que es this. So this is this, and this is that, and it's a cancel, and the answer is 1, and 1 equal 1, identity. Super good. Entonces, when you see pi over 2 minus something, this smells like a cofunctions formulas. Okay. Crystal clear or no? Confusing, very confusing.
It's clear.
Moving on to another example.
Professor, I have a question. Did you send this package that you are doing the exercise today? Because I didn't see it.
What package you talk about?
The exercise that you are solving now. Did you send to us or not really?
No, not yet.
Okay.
And I finished a lot of topic in the chapter 2. I sent you the fantastic package. Okay, we dedicate 2 or 3 lectures to solving everything at the beginning. Everything. Nuela, trigonometric inverse function, trigonometric equations, trigonometric identity, and another thing we cover, maybe not today. Okay? We go over again to this. Okay, one example, new one. Sine theta plus 1 plus 1 over sine theta minus 1 equal -2 tangent theta secant theta. Wow, what the hell is that? I'm totally lost, but I know the principle. What is the principle? Oh, it's obvious that you manipulate left hand side, it's more complicated. It's obvious also that never it's illegal to have 2 fractions separately. No, you integrate in only one. And it's obvious that the least common denominator is sine theta plus 1 times sine theta minus 1. And you divide this divided by this, multiply by numerator, get 1, get nothing is sine theta minus 1 plus. And this divided by this, cancel out, stays sine theta minus 1. Minus 1 or plus 1? Plus 1, plus 1. I mean, let me check it out. This divided by this is a cancel, yes. And this negative is cancel. Negative, this one positive and this one negative is cancel. And why not? Combine sine plus sine is 2 sine. Oh, and this is the famous multiplication, ¿no? Que es sine square theta minus 1. Yes or no? The difference of a square is a conjugate. They are a conjugate. Now what should I do? Well. Okay, I come back. This smells like this trigonometric. Look. Okay, I know que sine square plus cosine square es 1. Entonces, if you, for example, manipulate in your convenience sine square theta minus 1, I move this one to subtraction, I move this cosine to the other side, change the sign. I discovered that this is negative cosine, so I copy here. This is 2 sine theta divided by minus cosine square theta. Do you see that? This is complicated, eh? Or artificially, not complicated, no. Okay, now finally, I know that the answer is negative 2. Entonces sine divided by cosine, because I split this cosine into cosine. Entonces divided by cosine, and we have another cosine in the bottom, no? And this guy is tangent, minus 2 tangent. According to this trigonometry identity, look, tangent, cotangent identity, and reciprocal cosine is secant. Actually, this much better. It's secant. And this expression is exactly the same of the original. Look at that. Fantastic or no?
It is. So, Professor, you can give us an exercise that is not true. It's not true like the left side is equal to the right side.
Normally, the identity that you see in the test, in the review, in the book is true. And you need to prove it's true. Because it's frustrating, no? See, it's not true, it's untrue. There's no identity. What is the reason? You have 2 situations. The situation that I explained. One student solving one problem of the differential equation and get one solution using tangent, cotangent, and the teacher solving by himself and obtain different. And the challenge is proof that they are identity. The teacher says, no. My answer is okay. Your answer is a bullshit. You got 0 in the test. No, professor, look, this is identity. How you prove? It's not complicated by hand. Using the software, you put together, and when you press the button, say true, and this true change, get the 0, can get the student get 100 points. Okay? See, when you press the button, the software say false, the student stay in 0. Do you understand the idea? Yes or no? Noela?
Yes, Professor.
So never you see one situation and what is known true.
See, all the time it's gonna be true. We just need to prove
it. The idea is not true or false. It's true. You prove it's true. It's your job. Prove it's true.
Okay.
Okay. One more. We have time to start a little bit. Next topic. Okay. The last one is tangent theta divided by cosecant theta is equal secant theta minus cosine theta. Okay. In this case, I don't know why I select the left hand side, but it's possible to select the right hand side. Let's do it in both ways. Suppose I take this and copy again. Entonces tan I know que sine over cosine. This one. And cosecant is reciprocal of sine. Cosecant reciprocal of sine. Look at that. Okay, we have fraction, complex fraction. You copy the first. Multiplication by reciprocal of this sine. I have flipped it, no? So far we have sine square theta divided by cosine. But again, we come back to the famous, you use every day this. Is sine square theta plus cosine square theta equal 1, no? Okay, it's similar to say sine square theta alone is 1 minus cosine. You replace 1 minus cosine square theta divided by cosine. And you split again this common denominator, 1 over cosine minus cosine square theta divided by cosine theta. Bueno, it's obvious. This is secant, and this is cancelled out, no? At least one is minus cosine. Boom. This answer is equal to this answer. In this example, it's perfectly possible to do in another way. Manipulate this. Let's do it by curiosity. Just curiosity. Suppose the student say, no, I don't like this way, professor. You take this and manipulate this in order to get this. Entonces, 1 over cosine, because I know que secant, ¿no? Es reciprocal cosine minus cosine. There are no reason to have separate. You find the LCD. Entonces, this is 1 minus cosine square. Pero this is sine, ¿no? Square theta divided by cosine theta. Entonces you split. So you get the, look, you get this idea. ¿Qué es this idea? Let's do it backward. You separate sine theta over cosine times sine. This part. And you copy like that. Sine theta divided by cosine theta divided by reciprocal. 1 over sine. In my opinion, it's more, complicated to see. It's sine. And this is tangent divided by cosecant. Okay, it's exactly the left hand side. In my opinion, it's better in the way I did before. Huh? Yes or no?
It is easy.
This is, so if you select the wrong way, you have a big trouble because you complicate your life. So now, okay, so stop. I come back, right back, and take the other side. This is normally happen to me when I select one way, one side. I try to manipulate. I never get nothing important. So say I need to come back. Okay. We have 5 minutes, guys. I want to present the topic we discussing next time. Next time, we are discussing sum. So when you have two angles, and double angle and half angle formulas. Okay. This is extremely important in calculus. In calculus, we use it every day in the trigonometric thing. Wow. Okay. In the trigonometric thing, we're using some differences or double angle and half angles formulas. But let me start for this. Look, let me show you. So we pay our attention in this formula. Look. Today. Next lecture, no. But today we pay attention in this formula. Look. This formula, and this formula. Okay, I want to go a bit large here. Is sine alpha plus beta. Unbelievable, but true. The student try sine alpha plus sine beta. This is completely wrong. Okay? No. The formula is sine alpha cosine beta multiplication plus cosine alpha sine beta. The alpha beta is 2 angle. You see in the example the application of this. See S minus here. Makes sense, right? En cosine, no. En cosine alpha plus and minus beta is cosine alpha, cosine beta, minus plus, like completely opposite sign. So you see plus here is minus, you see negative plus, sine alpha, sine beta. And tangent alpha plus and minus beta is more complicated. Formula is tangent alpha plus and minus the same sign, tangent beta, divided by 1 minus opposite sign minus plus multiplication tangent alpha tangent beta. Okay, guys, this is the present the formula again. In the next lecture I want to repeat again the formula and let's see application of this. Okay, thank you, Professor.
Bye, guys.